Welcome to my presentation about Metro, a journey migrating away from Hilt. My name is Jonas. I've been an Android engineer for about 8 years, almost 9, and I've been at Ammo for close to 2. First of all, I have quite a few references and links in my presentation, so feel free to find the slides on speaker deck. I also have the QR code in the end if you want to wait with that. So, what is Metro even, you might ask, if you only have heard rumors about it? So, Metro is a dependency injection library for Kotlin. It's a compiler plugin, and it's authored by a guy called Zach. If you haven't heard about Zach, he's quite active in the community. He's contributed a lot to other DI systems like Anvil. He also made a presentation about Metro, which goes really into depth about the implementation and what it is and all its features. He did that in Japan last year. So for this presentation, I'm not going to go super deep into Metro and how it's implemented. I'm going to more compare it to Hilt, which is our previous dependency injection system. I'm going to talk about why you might want to switch, how you could do the switch, and what the result of switching is. So if it's not clear, we did do the switch. We did the switch back in September. First of all, so we're all on the same page. What is dependency injection? I'm sure you all know it, but I'm sure we all also wrote this code when we all started out. We're going to talk about, you have these dependencies, a service and a format. We're talking about this sample weather app I made. We have a weather service and a weather formatter that you need to create your weather app. And here we just create it in line where we need it. And you quickly realize that this does not scale. It's impossible to test. And there's a load of other issues with this. Of course, the solution is that you inject your dependencies either through a constructor or as a field injection, as you might recognize from activities and applications. So if you were to do this manually, you would, inside your application or your main function, you would create your weather service and formatter outside the weather app. You would inject it into the weather app through the constructor or through its field. And of course, we don't want to do this manually. So if you have ever used any kind of DI's library, you're just typically writing inject on your fields or on your constructor, and then you let the library do all the hard work. So Hilt, you probably heard about Hilt, but I'm just going to quickly introduce it. It's a dependency injection library for Android. Not Kotlin, it's for Android. It's implemented through an annotation processor, either KABT or KSP. It's built on top of Dagger, that I'm sure a lot of you have heard of. And it is the standard-ish library. It is the maintained and recommended by Google. And it's a great library, honestly. So why would you even want to switch? What is the problem? So this is a screenshot I took of our build scan many months ago. I have sorted these tasks by their duration. How long did they take to execute? And you'll notice that near the top, we have a few tasks named where the name starts with KSP. On top of that, we have a task which is a bit suspicious called compile Java with JVC. And the reason it's suspicious is that our app is 100% Kotlin, so why are we invoking the Java compiler? Well, it comes down to the way that Hilt and KSP works. So when you execute or run your app, first KSP is going to generate and output Java files. Of course, these Java files goes into the Java compiler, outputting class files that goes into the Kotlin compiler. And then even Hilt has even some extra steps in between. And this is a simplified version of how KSP and Hilt is executed. And with KAPT, it's even worse. You compare that to a Metro compiler plugin. It's just directly executed by Kotlin, by the Kotlin compiler, and the output, first it goes to something called internal representation. The next speaker is going to talk about what the internal representation is, so I'm not going to go into that. But the short version is that all Kotlin code becomes internal representation first, and then it becomes class files. So this is as close to the metal we get when it comes to creating tools. So because of this long execution or chain of events that KSP is creating for us, we have this setup in our products. For every feature, we have an API, a lib, and a bindings module. So these are Gradle modules, by the way. Again, we have Cyril. He made a talk about this last year, exactly why we do this. But one of the important points is that it's execution time, like how long does it take to compile? So for this reason, we only apply KSP on our bindings module. And I'm going to come back to why this is important. So let's get into what is the difference and what is similarities between Hilt and Metro by migrating this sample app I made. So I made this weather application with a weather activity with a weather view model. And these components is using a weather service that is as an interface that's implemented by a class. The things we're going to care about are these annotations, the Hilt Android app, the Hilt entry points, the Hilt view models. Yes. So the first thing you're going to do is you're going to go into your builder Gradle and you're going to include Dagger as an interop in Metro. So there's great documentation on the website about how you can adopt a Metro. There's been great thought gone into this. But the short version is that basically every annotation that works with Dagger, by including this line in your builder Gradle, now it also works with Metro. So let's start from the top. Let's first migrate our Android application. So if you're familiar with Dagger, you know components. If you don't know Dagger, component is where we are putting in all our classes, everything that is in our dependency graph. Notice I say dependency graph because it is a graph of our dependencies, and that is why Zach, he named his version of component dependency graph. For the purpose of this talk, you can consider these two one-to-one. They're exactly the same. The difference is that Hilt is, of course, made to be one-to-one with Android, whereas Metro is a Kotlin library. It doesn't know anything about Android. So to do the migration, all we have to do is tell Metro about a few Android components, and then we'd have to do a one-shot wiring of a few things, and then we're done. Never have to touch it again. So let's create our singleton component, or our app graph, as it's called. So first, you just create it as an interface. You mark it as a dependency graph, and then you give it the scope of app scope. App scope is Metro's version of singleton. Because we have the interop with Dagger, all your singleton annotations that you already wrote everywhere in your code, they're just going to work. You don't have to touch them. You don't have to change anything. It just works. Then you have to create your factory. This is so we can provide our application context or our application. Hilt does this for you automatically, but it's just 3 lines. It's not a whole lot. And then this is one of the things that Hilt also does for you. It binds the application to context automatically. So these 3 lines, binds, basically means that every time you're asking for the context, the application instance can satisfy this dependency. We have this application context qualifier, which is defined in the Hilt runtime. But again, it's a Dagger qualifier. And because we have interop enabled, this is just going to work. You don't have to migrate anything. You just have to define this line. Lastly, we might have some dependencies inside our application. I mentioned before we have field injection, and that I know there are other ways to inject in Android components, but this is the good old way of doing it. So now all that's left to do is actually creating our dependency graph. The way you do it, so we're inside weather application. I remove the Hilt Android application and annotation. And now I create my graph factory. If you look at the implementation of create graph factory, you'll find an empty function. And that is because the Metro compiler is going to implement this function for you. And what it does is that it sees that you want an instance of your factory. And it's just going to replace this whole function call with the actual instance after it's assembled everything with the modules and everything. And then you just call the create function, supply this, and you have your graph. Once you have your graph, you can then inject yourself For instance, if you want a logger or Sentry logger or Firebase or anything, this is the way to do it. Next step is our activity. So the Hilt way is just to use what's called the activity retain component. It's like the next step down from the singleton. It's a so-called subcomponent in Dagger terms. And the version of this in Metro is just called a graph extension. Again, these two terms are one-to-one. So if you already know Dagger, it's very easy to recognize in Metro. The way we define it, we just define it as a graph extension on the activity retained scoped instead of the app scope. The activity retained scoped is defined inside Hilt again, but it's defined as a Dagger scope. And because we have interop enabled, we can just reuse this thing. You don't have to rewrite anything or find and replace in your whole code base. This is this. And then you create your factory. You create it as a graph extension factory. And then the way it becomes a subcomponent or subgraph is that you contribute it to the parent scope. So in this case, the parent is the app scope, and you just contribute it. I'm going to get back to what contributes does in a little bit. So yeah, now you have your definition of your activity graph. So all you have to do is you have to grab your instance of wherever you store your singleton graph. In this case, it's the weather application. And now this is where the contributes works. Because I'm contributing to the parent scope, the parent graph is going to implement my factory for me, or Metro is going to make sure it does. And you can just directly cast your graph to the factory instance. And then you can create your activity retain graph. In this case, because it's a retained graph, I put it into a view model because that has the retained lifecycle. But you can put it wherever you want. Yes, and then you just keep going. Here I've created the activity graph, the view model graph. It's the same recipe. You just add the scope, add the factory to the parent scope. And if you forgot exactly how Hilt is doing it, they have this nifty graph in on their website. If there's some of the components you don't use, obviously you just skip it. We don't use the fragments, for instance, so we don't need to create that. All right, so now we have our bindings. So what is a binding? A binding basically is just anything that's available to the graph. And typically in Dagger, you would create this through modules. And similar in Hilt, since it's Dagger, we're also creating modules. So here I create and bind my weather service to the graph. And I do that with an interface annotated with module. And there's one thing that Metro doesn't do, and that is the install in. Install in is Hilt specific, so we're going to have to migrate that thing. Luckily, it's going to look very, very similar in Metro. We're not calling it module, we're calling it a binding container. But since we have interop enabled, you don't even have to find and replace that. This is just to show. So the things we have to focus on is the install in is now called contributes to. So actually in this case, because it's contributed, but it's also a binding container, you're not gonna have one class that is gonna extend 1,000 modules. In this case, Metro is just gonna use the binding container and the information within to wire up the graph. But actually, Metro has an even shorter way of doing all of this. And that is you just create the binding straight on the implementation. That keeps everything very centralized and much easier to handle. You don't have to go through a billion different modules. View models. So actually, when we did this migration, we did not have access to this library. It had not been released yet. But luckily for you, you can just go to the documentation and use the first Metro X library called Metro X View Model. There's also Metro X View Model Compose. I'm not going to go through exactly how to set it up. The documentation is excellent. But the short version is that you create your Metro View Model factory. You bind it into some sort of scope. In this case, it's the app scope. I think we do it into the activity retained scope, but you choose whatever hierarchy you want. Then you have to change your view model from being annotated with Hilt view model to have a multi-binding into map, and you have to give it a view model key. You can also do this in your modules if you already have this whole mapping set up, but this is the way to do it. And then inside your composable or inside your view, you replace Hilt view model with Metro view model. It's pretty simple. Yes, and then as a small bonus, I've also shown how to do entry points. If you don't know what an entry point is, it's just a way to get access to your graph from anywhere in your app. So in this case, we're using it to inject into our composables. So composables are just top-level functions, so you can't really inject it. Or maybe you can. But in this case, we're just going to use a local view graph, a composition local, to inject the graph into our composables. Then we're going to create a contribution, because in this case, we want to maybe access our formatter from within to put it into a text composable, for instance. You will notice that this is not a module. It's not a binding container. So this means that our view graph is now going to extend this interface, and it will give you access to the weather formatter. And I create a small utility function, so I don't have to cast everywhere. I just ask for a contribution of a certain type. And then you have to, of course, remember the instance. If it's not scoped, it would always return a new instance every time. I want to mention that this contribution is actually a built-in function as well. There's a built-in as contribution. The reason we don't use it is that it only works for top-level dependency graphs, so it does not work for graph extensions. And I think it also only works if it's within the same module. But if you are so lucky that you can use this, actually the Metro compiler will actually check that this cast will succeed. So you get compile time safety. So what are the results after we did all these changes? We removed all our modules, we removed all our extra Gradle modules as well. The result is that we removed a fourth of all our Gradle modules. Why does that matter? Because if you ever wait for Gradle sync, you know that more modules is more weight. So in this case, we went from almost 500 down to 350. You might ask, why is it not 33%? It's because some of our Gradle modules didn't have a binding, did not have anything to inject, just utilities. We removed 2.5% of our lines of code by removing all of our modules, and less code is less weight for compilation. Gives some nice PRs as well. But the big one is the build times. So what happened to our build times? So what I did is that I assembled our app in debug mode. This is where Metro really shines. It is when you are continuously developing, you make an API change to your implementation. API change is any change to a top-level interface function. But yeah, this is the result. So if you did that change with Hilt, it would take 24 seconds at a medium-sized module to recompile. But if you do it with Metro, it's now around 8 seconds. This is a 65% decrease in compilation time, something that we've been pretty happy about, even though less time for TikTok. And there's also on Zach's website, on the documentation, there's a page about performance. I know in every CI, every time he pushes to main, there's a CI step that now remeasures compilation time. There's other companies, Square, Cash App has also contributed their speedups. I don't remember, but all of them are somewhere between 50 and 80% speed up in compilation time. I will mention that it's only 2 API changes. If you do a clean build, you're not going to see huge increase in or performance gain, but still something. And now we're talking about build time. So why would we not choose Coin, for instance? Coin has 0 overheads when it comes to a compilation. And the thing is, for us, we really want this static analysis. We want compilation to fail if something is wrong. We don't want to find out later. We don't want to find out in production. But, you know, there's a Coin annotations. Why not use that? Well, Coin annotations uses KSP, and that kind of takes us back to square 0, right? we wanted to avoid using KSP. I said many good things about Metro. Are there any bad things? It's still a pretty new library. It's a little over a year old. It's still not V1, so there are still some baby issues. We're still running into some error messages that doesn't really make sense, but they are definitely becoming fewer and fewer. And then because it's a Kotlin compiler plugin, it's very tied to the Kotlin version. And it turns out that Kotlin, Android Studio, especially if you're on Canary or Reese candidates, they ship with like a random Kotlin Kotlin version. So Android Studio support is a bit experimental right now. So yeah, I'm near the end. There was a lot of things I did not mention in this talk, but I will say Metro is pretty much on feature parity with Dagger. There are multi-bindings, optionals, there's assisted injection. Multi-platform it also has, which is something Hilt does not have. And then it also has even more magic, because when you're a compiler plugin, you get to do more magic than when you're just writing code. So you can actually inject your top-level functions. I urge you to check out the documentation and see how that actually works. But yeah, it's pretty magic. Thanks.